Now let us see more formally how we can put this finding the optimal binary search tree for the example shown here. In this example, we have 4 keywords which are listed under A. The keywords are do, if, int, and while. And the probability of being used are 3311. Yeah, this whole thing is converted into integers for simplifying, but in reality these were probabilities. So something like 1 2 3 4 5 6 7 8 9. So it may be 3 by 9, 3 by 9, 1 by 9, 1 by 9, 2 by 9, 3 by 9, 1 by 9, 1 by 9, 1 by 9. So that way might be. And two, in order to avoid unnecessary complications in computing with fractions, we have taken only the numerators. So that's what we want to tell before beginning it. But in reality, P and Q's are the probabilities. Now what P is? P is the probability of the keyword do occurring in your program text. 3 is the probability of keyword if occurring in the program text, and so on. Now coming to Q. So if you look at the dictionary, now there are a lot of words in the dictionary. So before do there are many words. Yes, there are many words, but all other words are not going to be put in your program text. Few of them may be put in the program text. So this is telling out of the whole words in the program, how many belong to this part. So that's a ratio of the words in the text belong to this particular scenario. Then the second one, 3, is the number of words from which occur in the dictionary from do to if, at all words are possible. So how many are used in the text? So some 3 is its value. Same way, between if and int any word occurs, then it is used once, and between int and while it is once, and coming after while it is once. So this part is, this is Q0, Q1, Q2, Q3, and Q4. So in all, our whole thing, in if you arrange them in the dictionary, it would look like Q0, P1, Q1, P2, Q2, P3, Q3, P4, and Q4. Yeah, wherein P1, P2, P3, P4 are what we are looking for, and all other things which are not keywords are put under Q0 to Q4. Done. So that's the preview for this problem. Now, how to solve this problem? We look, there are many ways the tree can be built. So for every word, keyword, we can build a subtree. So that way we can talk about subtrees. Then the next level of subtrees, then the next level of subtrees. So first level of subtree with single keywords, then two keywords together, then three keywords together, and so on. Done. So how do we solve? So let's begin our work. So our first step is single keyword at a time. So if we talk of single keyword at a time, then it will be P1, Q0, Q1, P2, Q1, Q2, P3, Q2, Q3, and P4, Q3, Q4. So we are talking between the keywords. So if you look for P1, yeah, what is the probability of P1? It is 3. For Q0, it is 2, and Q1, it is 3. P2 is 3, P3 is 1, P4 is 1, and Q2 is 1, Q3 is 1, Q4 is 1. Done. Okay. Now, if we have this type of tree, 4 trees are possible. So, what is the average time, number of what you call? What is the average number of, or the total number of search required for this tree? Yeah. So we are looking for something. So if it is this tree, then we search at this root, and so it is the first search. So 1 into 3. If it is there, done. If it is not there, then you know it is less than that or more than that. If it is less than that, you have to go here. If it is more than that, you have to go here. So you don't require one more search. So just one search is sufficient to take care of that. 1 into 2 plus 1 into 3. So that makes 1 plus 2 plus 3, which is 8. So this side, it is 1 into 3 plus 1 into 3 plus 1 into 1. Because only one search is for the keyword. At keyword you search it. You don't search in this, because this is just a collection of all the unknown words which fall below P2 but above P1. After P1, before P2, whatever come under Q1. Therefore, there is no meaning in searching, because we don't have anything to search here. What we are searching is it P1 or P2 or P3 or P4? So if you look for this, then that's what it says. So 3 plus 3 plus 1, that is 7. Now coming to this, 1 into 1 plus 1 into 1 plus 1 into 1. So that makes 3. Same way, this is also 3. So that's first step. Then going to second step, 2 keywords at a time. So when you say 2 keywords, It may have P1, P2, or it may have P2, P3, or it may have P3, P4. So there are three possibilities. So last time there were four possibilities. Now we are having only three possibilities. So how does that look like? So now we have two nodes which are important, P1 and P2. So in this case, we can say P1 can be root and P2 can come here. If P1 is root, then Q0 should be its left child, and P2, Q1 should be to the right of P1. Yes, to the right of P1, but left of P2. So Q1 comes here, and of course Q2 comes here. Same way, if you talk of P2 in the root, then P1 should be here. Then if P1 is here, then Q0 will be here, and Q1 is between P1 and P2. This is above P1 is this, but below P2 it should be. Then you will get Q2. So two trees are possible for this. So what are the answers? So let me just separate it so that computation can be simpler. Done. So what are the values? P1 is 3, P2 is 3, Q0 is 2, Q1 is 3, Q2 is 1. Right? 2, 3, 1. 2, 3, 1. And P's are 3, 3. Done. So this is 3, this is 3, 2, 3, 1. So if you look at it, P1 is on the root, so it will be used to search once. So 1 into 3. P2 is at second level, therefore to reach P2 you should you should first look at the root, and root says no, it is greater than what is at root, so you have to go to the right. At right, ask the question again, is it P2? If yes, then you have the answer. So it needs two questions, one at the root, one at this, so 2 into 3 plus. So to go to Q0, how many questions you want to ask? Yes, of course, only one question. So is it some word which comes before do? So maybe we can use some examples for this. Maybe B between do and if is if and int. Maybe in between int and while. So after while, okay, let's take this as example. So looking for B. So is this B? What is here? Here is do. Is it B? No, it is do. So where B can be? B has to be on its left side, because B comes before do in the dictionary, so it's on the left side. So B is not part of our keyword, therefore I don't again look for is it B. No, I don't have to search, because we are not searching for B and all that. We are searching for do, if, int and while. So therefore we don't ask any question. So one question was asked here, so the one question is sufficient. So we have possibility of having two. Okay, that is for 1 into 3. and 2 into 3. Then for Q0 it is 1 into 2 for Q1. To reach Q1, what is Q1? Is. So is this is? No, it is do. So where do you find is? So go to the right. Is it is? It says no, it is if. Then where do I find is? It says go to the left. So two questions. So 2 into 3 plus this also will have two questions. 1 into, sorry, 2 into 1. So that makes 3 plus 6 plus 2 plus 6 plus 2. 8 plus 8, 16 plus 3, 19. Same way, if you talk about this, then it is 1 into 3 for the root, then 2 into 3 for P1, then 2 into 2 for Q0, then for Q1 it is 2 into 3, and finally Q2 you reach with only one question asking at the root, therefore it is 1 into 1. So that makes 3 plus 6 plus 4 plus 6 plus 1. So 10, 16, 17, 20. Now which combination is better? Of course this combination is better if we ask for P1, P2. That means you start from Q0, P1, Q1, P2, Q2. So this, let us call it as 0 to. This one is 0 to 1. This is 1 to 2. This is 2 to 3. This is 3 to 4. This starts from Q2, Q1, Q0, ends at Q2. So 0 to 2. So this starts from Q0, ends at Q1. So 0, 1, starts at Q1, ends at Q2, 1, 2, 2, 3, 3, 4. So this convention let us use, and let us see how this thing can be further improved. Yeah, unnecessarily I think we are wasting our time, because I think this we had already solved. P2 at the root. Yes, we have here P2 at the root. What was it saying? 7. Okay. Then this one already there. P1 at the root. This said 8. Okay. Then how do I connect this 7 with 19 and 8 with 20? Yes. So can we add them? 7 plus 3, 10 plus 2, 12. No, doesn't make sense. 12. Okay. What about this? 8 plus 3, 11. 11 plus 1 is also 12. So what is that 12? 12 is 3 plus 3, 6, 6 plus 3, 9, 9 plus 1, 10 plus 1, 11. So it is just all the weights added together is 12. But we want 19. Where do you get 19? If I add this 12 and 7, I will get 19. If I add 12 and 8, okay. Okay. So we can try this way. That means instead of doing this all big circus, what we can do is, one thing is, take all the weights, what we call these numbers, we call the weights because we are talking in terms of tree. So add all the weights. So this is sum of the weights, and this is what you got from the previous one, right? So this is what you got previous one. So previous one plus the current weights may be, we have to check that. So let's try another one to ensure that. So that is Q1 to Q0 to Q2 is over. Now you start from Q1 to Q3. So the next thing is Q1, Q1, P2, Q2, P3, Q3. So what all possible ways are there? So it can be P2 on the root, P3 here, or P3 on the root, and P2 here. So if P2 is on the root, then definitely Q1 will be here, Q2 will be here, Q3 will be here. If P2 is on the root, if P3 is on the root, then P2, it is surrounded by Q1 and Q2, and after P3 you get Q3. So all these things, Q1, P2, Q2 should come before. Okay. Now values, P2 value is 3, 1. This is 3, this is 1, Q1, Q2, Q3, 3, 1, 1. Okay. So this is one question is asked here, second question is asked here. That means this you get with one question, this we get with one question, this we get with one question. This needs two questions, this needs two questions, this needs two questions to reach. So that is 3 plus 3 plus 2 plus 2 plus 2. So 2 plus 2 plus 2 is 6, 6 plus 6 is 12. Okay. So coming here, P3 is 1 and P2 is 3 and Q1 is 3, Q2 is 1, Q3 is 1. Then this P3 is on the root, so you need one question. P2 is at the second level, so you need two questions. This requires one question, this requires two questions, this requires two questions. So 1 plus 6 plus 6 plus 2, 6 plus 6, 12 plus 2, 14 plus 2, 16. So of course this looks better. So as per our previous thing, I think this was already done. This was already done. P3 at the root. P3 at the root we got a 3 and P2 at the root we got a 7. Okay. Now will that previous logic make sense? The total weight was 3 plus 3 plus 1 plus 1 plus 1. So 3 plus 3, 6, 7, 8, 9. So total weight makes 9. So this total weight also should be 9. So 9 plus 3, 12. Oh God, working. 9 plus 7, 16. Yeah, that's also working. Okay, that means last time I had wasted so much of time in computing. This time I just used this thought to be a shortcut, and definitely it worked. Anyway, I'm not still sure whether it works for the next one, which is Q2 to Q4. So Q2, P3, Q2, P3, Q3, P4, Q4. So in this case, one option is P3 can be at the root and P4 can be here. P3 is on the root, then Q2 should come here, Q3 should come here, Q4 should come here. And other option is P4 can be on the root, then P3 must come here, then it is Q2 here, Q3 here, and then Q4 here. Okay. So P3, P4, 1, 1. Done. Then Q2, Q3, Q4, all are ones. Okay. Then if you look for the number of times, so this is asked one question, this needs two questions, this needs single question, this requires two questions, this requires two questions to reach there. One question is asked at P3, one question is asked at P4. Okay. So that makes how much? So the total is supposed to be 1 plus 1 plus 2 plus 2 plus 2. So this is 6 and that's making 8 is the total weight. And how about this? Not 8, sorry. One plus 1 plus 1 plus 1. So 5 is the total weight. And looking for this P4 as the root. So it is 3. So that makes 8 or 1 plus 1 plus 2 plus 2 plus 2. So if you use the product, so it is 2 plus 2 plus 2, 6 plus 7 plus 1, 8. Okay, in this case, P1, P4, one question required. For P3, two questions required. For this, one question required. For this, one required. For this, two required. For this, two required. So the total is supposed to be 1 plus 1 plus 2 plus 2 plus 2. So that also makes it 8. 2 plus 2 plus 2, 6 plus 2, 8. So will that match with our logic? The total weight, just the green part, if you add 1, 2, 3, 4, 5, 5 are there in the green. And what is this? P3 at the root. P3 at the root, it is 3. Yeah, 5 plus 3 makes it 8. Okay. So in all, what we can say, the total of if you say cost of I to j, or something, if you are talking of this, then this will be some subtree. So something what we can say is the total weight plus the previous subtree. Subtree cost. So weight is 5, subtree cost is 3, so that makes 8. Weight is 5, subtree cost for this also is 3. So something we are able to make up. I'm still not sure will this be correct one or not. So that's where we reached. So second part is over. Now getting to third part. 3 keywords together. So three keywords together means P1, P2, P3 together. So one option is Q0, P1, Q1, P2, Q2, P3, Q3. Then what all possibilities are there? So one way you can think of is take P1 here, then you are left with Q0. Then what comes here? What comes here is this whole thing. Q1, P2, Q2, P3, Q3. So I think we have solved this Q2, P3, Q1, P2, Q2, Q1, P2, Q2, P3, Q3. We have already solved it. So why not take this whole thing? So what should I call this? It starts from, yes, it starts from 1 ends at 3. This starts, so this is 1, 3. What about this? This is 0 to, starts from Q0, goes to Q2, and this one starts from 2, goes to 4. So we have 0 to 2, 1 to 3, or 2 to 4 as two keywords combination. So this is what should I call Q1 to Q3. So this I can call it 1 to 3. 1 to 3 we have solved already. Which one should I take? So definitely I should take the 12. So its value is 12. What was the total weight here? Because I have to make the weights also. So what was total weight here? Total weight here was 9. 3 plus 3, 6, 7, 8, 9. So the weight was 9. Okay. Now what is the P1's value? P1's value is 3, Q0 value is 2. So what we have to do is the total weight. Total weight is 5 plus 9, which is 14, and add 12 to that, and that makes 26. Okay, then you can take P2 as the root. Then you start from 0, 1, and here 2, 3. So 0, 1's weight, 0, 1's weight 8. 0, 1's weight is 8. The value is also, cost is also 8, and 2, 3, 2, 3. The weight is 3, cost is 3, and P2 value is 3. So these are weights. So what we need to do is just add up all the weights. So 8 plus 3, 11, 11 plus 3, 14. So weight is going to remain same whether you arrange this way or this way, but cost is going to change. The cost is 8 plus 3 to be added, which is 11. So that makes 25. Okay, then P3 can be on the root. If P3 is on the root, then 0 to 2 comes here, and Q3 comes here. So P3 is 1, Q3 is 1, 0, 2. Yeah, 0, 2 we have just solved. The weight of 0, 2 was 12, and the value was 19. So we have to use this one, not this one, because it's 20. So 0 to weight is 12 and total is 19. Therefore, you have weight as 12 plus 2, 14, same as other, and 19 as the earlier cost. So that makes 33. So which one is better? Of course 25 is better option. So that is 0 to 3 is over. What is left now? We are working with 3 at a time. 1, 2, 3 are over. So 2, 3, 4 we have to check. P2. So it will start from Q1, P2, Q2, P3, Q3, P4, Q4. That means we are working on 1 to 4. This was 0 to 3. Okay, 1 to 4. P2 can be on the root, and here it will be 2 to 4. Okay, P2 is 3, Q1 is 3, 2, 4. What is 2, 4? 0, 3, 2, 4. 2, 4, the weight was 5 and cost was 8. Weight is 5, cost is 8. So if you look for weight, 3 plus 3 plus 5 is 11 and plus 8 to be added. So that makes 19. Okay, then P3 can be the root. If P3 is on the root, 1, 2 will come here and 3, 4 will come here. Okay, P3 means 1, 1, 2, 1, 2, 1, 2, yeah, 1, 2. 1, 2 is 7, weight is 7, cost is 7, and 3, 4, 3, 4, weight is 3, cost is 3. So the weight is 10 plus 1, 11, and the cost is 7 plus 3, 10 to be added for the previous one. So that makes 21. And for P4 at the root, 1, 2, 3 comes here and Q4 here. P4 is 1, Q4 is 1, 1, 2, 3. 1, 2, 3 we had just used here, 9 and 12. So the weight is going to be 11 as usual, but the cost is going to be 11 plus 12, that is 23. So 19, 21, 23, therefore this is preferred, these two are not preferred. So all 3 keywords means 0 to 2 is one option and 1 to 3 is another option, 1 to 4 is another option. So you will get only 2 options. Now finally 4 keywords together. So in that case P1 may be root, Q0 here, and then 1 to 4 here. So if you look at this one, if you take P1, Q0 comes this side, 1 to 4 this side. Right. If you use P2, then 0 to 1 comes this side and 2 to 4 comes this side. If we talk of P3, 0, 2 comes this side and then 3, 4 comes this side, and finally if it is P4, then 0, 3 comes this side, Q4 comes this side. Okay, Q naught is 2, P1 is 3, 1, 4, 1, 4. 1, 4's weight is 11 and 19. Which one we should use? This 11, 19. Okay, 0, 1. 0, 1 is 8, 8. P2 is 3, 2, 4. 2, 4. Weight is 5. Cost is 8. Okay, P3 is 1, 0, 2. Where do we have 0, 2? Is it 0, 2? Yeah, 0, 2. Yeah, 0, 2. 0, 2 is 12 plus 12 and 19. 3, 4. 3, 4 is 3, 3. 1. 0, 3. 0, 3, this one. So the cost is, the weight is 14, cost is 25. And Q4 is 1. Okay, now 13 plus 3, 14 plus 2, 16 is the weight, and 16 plus 19, that makes 35. Yeah, of course, now also 16 should be weight. The only thing is, to that 16, another 16 should be added, that makes 32. Here 16, 19 plus 3, 22 is added, and that makes 38. And to this 16, 25 is added, and that makes 41. So what is a minimum? Minimum is this. So that means P2 should be at the root. Done. Then P2 at the root, then left side is 0, 1. Left side is 0, 1. 0, 1 means P1 and right side is 2, 4. What is 2, 4? 2, 4. Which one we should use? Both are equal to 8, so anything you can use. So I can use P3 in the root. So if you use P3 in the root, then what you get is Q2 here, P4 here, Q3 here, Q4 here. So this is the subtree we are talking of, this left one, this one, or you can use this one also. So this is one option. Second option is P2, P1, Q0, Q1, P4, P3, Q2, Q3, Q4. So both these subtrees are for 2, 4, and both are giving a cost of 8 only. So doesn't make a difference whether use this subtree for 2, 4 or this one for 2, 4, because cost is 8 in both the cases. So we have totally two optimum binary search trees for this given problem. It can be either this or this. So that's it for now. Yes, of course I understand these things are not very clear, so I think this can be simplified and put in a better way. So let's make use of some more examples in the coming sessions and try to understand this in a better way. So keep watching. Thank you.